45 watt light bulb and a 40 watt light bulb are connected to a 120 voltage source. That's common in households, 110, 120. Let's see, determine the voltage across each light bulb if they're connected in series and then if they're connected in parallel. Okay, so as we're going to see here shortly, when we have an AC source called an alternating current source, the symbol for that is a sine wave shape. So instead of the DC battery that we had seen in the past that looked like this, that would be for DC. We're going to now start to see what is called AC sources. Okay, and that would be alternating current. Okay, as opposed to direct current. Okay. So now let's hook up this AC source to these bulbs. First we'll do it in series, and then we'll do it in parallel. We're going to have 120 volts, and we want to figure out, first of all, what is the resistances of these bulbs. So when a bulb is given a wattage like 100 watts or 45 watts, it's assumed that it alone is attached to 120 volts. So with that in mind, just on the side, before we wire them in combination, I'm just going to do one alone, right? So 120 volts, and this is a 45 watt bulb. We want to find out what its actual resistance is. Okay, so to do that, we'll start from the formula P equals V times I. All right, the power should be plugged in, 45 watts. And the voltage, 120 volts. And then we could find the current there. But there is actually another formula for power that would help us find the answer a little bit quicker. And that formula would be power equals V squared over R. So we'll have 45 watts equals 120 volts over R. Now I'll solve for R. Alright, so I'm getting 320 ohms for that. Alright, so the 45 watt is 320 ohms. Okay. Now let's do it again for the 40 watt. So the power of the 40 equals 120 volts over the R of the 40. So $360 ohms. Okay. So let's write that in as well. Alright, if we combine the resistances into one using the rules for series, we'll get 680 ohms. How do you think the brightness compares with the original setup versus the new setup? Like, will they still be 45 watts? of power and 40 watts of power? Or no? What do you think? Will the brightness stay as bright as it was originally, like just with one bulb in the circuit, or will the brightnesses actually go down? Take a guess for yourself, and now we'll calculate like whether they would still be emitting the same power as before, or will it be less. So in order to figure that out, I want to find the new current. Okay, so I'll do I equals delta V over R EQ. So 120 volts, 680 ohms, and I get 0.176, okay, amps. Now in order to find the new power, we could go on to find the voltage in each. So let's do that. We know the current, we know the resistance, so the delta V of the 45 will now be the current times the resistance, 0.176 amps, 320 ohms, 56.5 volts. Okay. And let's find the voltage of the 40 as well. .4 volts. Alright, so not surprisingly, the one with the higher resistance drops more voltage. But now we want to use the other power formula to figure out the new power of the 40, Is it still 40, or is it something else? And then we'll do the same for the 45. Okay. So 56.5 volts times 0.176 amps, 9.9 watts. Okay. And then we'll do the same for the other. I get 11.2 watts. Okay, so when you do wire more and more bulbs in series, this increases the resistance of the overall path. For that reason, the amount of current flowing through them is going to be less, and they're not dropping as much voltage as they would have been alone. Like when he was alone, dropped the entire 120 volts. So it's pretty bright. But when they are dropping less voltage and less current across them, not surprisingly, they're going to be dimmer. And so a bulb which is rated at, say 60 watts or 45 watts or 40 watts, that assumes that you're connected to your own line on 120 volts. So as we can see, the power here does change. So a 45 watt bulb is no longer dissipating 45 watts when it's in this configuration. To answer the question of this homework question, we should put in the voltage dropped by the 45, which is 56.5 volts here. The voltage dropped by the 40 was 63.4 volts. And now what's going to happen in parallel? Okay. So in parallel, Each of them gets their own branch. Okay. And we know for parallel branches, they're going to all drop the same delta V of 120 volts. So when we go to calculate the power for them, this is where the power will be what was expected. What we can do is we can do those calculations just to prove it. But first, to answer the question, 120 volts for both, right? Let's go ahead now and let's do the calculations for what it would be in parallel. Okay. Okay. We have 120 volts here. Our resistance of our 45 was 320 ohms. Our resistance of our 40 is 360 ohms. And I just want to calculate what current is going to be developed in those branches, right? So the current for the 45 will be the delta V of the 45 divided by the R of the 45, right? So that's going to be 120 volts, 320 ohms, 0.375 amps. So wow, look at the jump in current. Before it was only feeling 0.176 amps. Now it's going to have 0.375 amps going through it when it's in parallel like that. And that's what makes the power 45 watts. Because you multiply the 120 times the 0.375. Now we'll find the current in the 40. $120 volts, 360 ohms, 0.333 amps. And it's a 40-watt bulb. Look at the current that's drawn, though. If you were to add them two together to get the total current, okay, it's going to be the sum of them. We're talking about 0.708 amps. So which one is correct for the way that a household actually wires light bulbs, for example? Is it series, do you think? Or do they actually do it in parallel? What do you think? Well, the answer is parallel. You know that when you turn on more lights in your house, they don't go dimmer, do they? They stay at a constant brightness no matter how many lights are on. So this is actually the way that the household wiring is done. Okay, so every light should have its own parallel branch where it's connected to a breaker, for example. And I believe some of the questions that are coming up soon are about fuses and how current can get to be too much, and it could be dangerous in some situations. You can see how adding an extra branch here just is going to increase the total current that's being drawn, from the source. So